Hi everyone, here is another example of calculating with probabilities for data that is normally distributed. And this example I'm working through is question 3, part A, from the homework packet in homework assignment 9-10. And I showed how to open this homework packet in my previous video demonstration, calculating probabilities, that demonstration. So please feel free to take a moment, rewatch the beginning of that video if helpful, and open the file and question 3 so you can follow along. And here we can see the question. And as usual, I start by actively reading the question, underlining things I find useful to know. And now, what is useful? Well, I'm going to come back to this question at the end, but see if you can tell what information I think is important based on what I underline and what I emphasize. Oh, and speaking of emphasizing, here is one more important point, that the calculations that we are doing in these types of exercises, these calculations aren't the answers in general to statistical questions. The calculations aren't the answers. The calculations are what we use in order to answer the questions. And I'm sure that I will talk about this, and hopefully this becomes clear as we're doing this part A exercise. So I'm going to briefly pause my speaking, and we can read part A to ourselves. Please feel free to pause the video if you need or want more time. Again, I'm pausing my speaking. So in this exercise, here I'm taking some data, and I'm assuming that human body temperatures are normally distributed. I'm told here's some body temperatures. This data from research at the University of Maryland found body temperatures, and we're assuming they are normally distributed based on what I see from that data, normally distributed with a mean of 98.2 degrees Fahrenheit and this standard deviation. And I'm curious to know, I work for example, emedicinehealth.com, and according to them, they suppose that a temperature of 100.4 degrees Fahrenheit or above is considered a fever. And what percentage of normal healthy people would be considered to have a fever with this criteria? I guess that's a question we'd be interested to know. What percentage of normal people, or people who do not, average healthy people, would be considered to have a fever with this criteria? They ask another part to this question. Let's just start with this. What percentage? Well, because I already know in my own since I've already talked about in the past, we've all talked about in the past, that when it's asked to find percentages, that's the same thing as for a normal data model, knowing about areas under that normal curve. So when it's asking what percent of normal healthy people would be considered to have, again, a temperature of this or above, I'm going to be following steps for finding probabilities, which is to draw the curve, shade the area, find that probability, and most importantly, interpret it in context. And you've seen me, I've already started now to draw this curve and label the points that I'm interested in. You can see that I've gone and I have started by saying, okay, here's a normal model for data with this mean, and if it has a standard deviation of 0.62, I automatically know more information about this model. Like, for example, that almost all of the data, 99.7% of the data, would be between 96.34 and 100.06. 99.7% of all human temperatures would be between these two temperatures if it's true that the data follows a normal model. And they're asking us specifically about, okay, what about a body temperature? What about a body temperature of 100.4 or more? Okay, 100.4, where is 100.4? You have 100.06. Well, where would be 100.4? It's actually pretty high up there. I mean, that's where it is. And if we're interested to know what percentage of people would have that temperature or above, well, just so that I have it for myself, let's shade that area that I'd be interested in. Let's shade that area. Shade that area. What would it be? Well, it's a pretty small percentage right here, right? It's way up there. Okay, well, let's just know what is that percentage. Let's calculate that number. Okay, so to calculate percentages, finding those proportions, that area under the curve, I can either use the empirical rule or paper, a normal table, or technology, and that means calculators, online calculators, and since I've used the online stat book calculator before, I'm going to use that again here. And to do that, I go to a new window for the internet. I type in normal distribution calculator. You can also do normal distribution calculator by online stat book, or if you are following from my class, there is a link to that page on my RCC. Once you type that normal distribution calculator in, the first link will be an example for what we are used to looking at in our class, and this layout is familiar. Again, this is the normal distribution calculator, where they give you the instructions on the side and ask you to specify things like the mean and the standard deviation. Well, in this data that I'm assumed to have a model 98.62, zoom in a little, scroll down, the mean is 98.2, the standard deviation is 0.62, and as I said, because it helps to sketch your model by hand, we can prove that these temperatures are similar to the temperatures I've drawn on my paper. And I wonder why this number hasn't appeared. Certainly I calculated it on the other page, but for whatever reason, okay, here is what the data would be distributed like if, as we've assumed, the normal model for data applies to this temperature data that Marilyn collected. And I'm curious to know what proportion of all these temperatures are above what? Above 100.4 degrees. And once I hit recalculate, let's see what shaded area would be above 100.4. And where is it? Well, it is so small you can barely see it, just like we saw in the shaded area on the other page. So what is that probability? What is that percentage? 0.0002. 0.0002 is that area. If I go back here, 0.002. Remove that for a second. 0.0002. What is that as a percentage? That's 0.02%. Pretty small number, right? And now we get to the heart of the problem. We get to the heart of the problem, which is asking us, the heart of the problem is asking us, does this percentage suggest, does this percentage here, does this percentage suggest that a cutoff of this temperature, 104, is appropriate? In other words, I mean, has eMedicine Health made a good choice for a cutoff? Is it too high? Is it too low? I mean, well, this is, I suppose, where we have to think about it a bit more. And the answer to this question is up to you, or perhaps the doctors who are making this decision. I mean, it doesn't matter exactly what words you use for the answer to this question, as long as you can justify your answer and the answer makes sense. Your answer, does this percentage here suggest that it was a good idea to use this 104? Well, I don't know about you. It doesn't. I mean, here's my answer, and as I said, it doesn't matter the words you use as long as you can justify your answer. What in my mind I said was that, okay, since the percentage of temperatures above 100.4 degrees is 0.02, well, and like the most important part is really, I am not a doctor. If I had to write something else for myself, I would say, I am not a doctor. as I write this out. You can see it appearing on the bottom of the screen. I'm not a doctor, but it seems like a small percentage. And because I'm not a doctor, it seems like a small percentage. Maybe this is a cutoff that is too extreme. I'm not a doctor, but if few enough people are being considered to have a temperature, then, I mean, maybe what if someone has a temperature of 100.01, something in here? Should that also be maybe considered as a temperature that's a fever? Well, this is something for us to think about independently. Obviously, if you are involved in the field of medicine, you might have more information. For example, you might be more used to seeing people with certain symptoms who have maybe, as I said, a temperature of 100.1. You could maybe answer this question better. And now, coming back to that question that I said at the beginning, I'd come back to, like, what is useful for answering questions like this, question 3, part A? Well, questions that you'd ask yourself as a statistician. Any type of question like this, really what you want to be able to ask yourself are, well, what type of data am I working with? I mean, really, what question do I need to answer? What is the question I'm being asked to answer? And it helps to know, does this data have a known distribution, like a normal distribution, which allows us to assume automatically certain things about temperatures, in this case data related to this scenario. And just to summarize this video, we've identified the question that was asked of us, we've used the steps, identified it was to find a probability, a percentage, proportion. We identified and used the steps to calculate the percentage, and more importantly, therefore, to answer this question here, does that percentage suggest that a cutoff is appropriate? And the steps taken for any statistician when answering these types of questions are these ones above. So, thank you for your time. I will continue with part B very soon, and I look forward to seeing you in that next video.